can summarize the nature of roots as follows. So if the discriminant is less than 0, we end up with a negative inside, and we can't square root the negative. Therefore, we have no solution, or what we call imaginary roots. If the discriminant is equal to 0, so the inside is equal to 0, we end up with plus minus square root of 0. So plus minus 0 does not give us two unique solutions. It gives us only one solution. Sometimes we call this two equal solutions or two equal roots, but basically it's one answer where it's bouncing off the x-axis. When the discriminant b squared minus 4ac is bigger than 0, we get two solutions. Okay, so because we're going to plus minus some square root amount, that means that we start at the center, we're going to plus some amount to get to one root. We're going to subtract some amount to get to another root. So basically it looks like this. If I have zeros here, there's my center. I'm going to add the square root amount to get to the 0 here, and I'm going to subtract some square root amount to get to the 0 there. And I'm starting at my vertex to do that. So you should notice that in the quadratic formula, negative b minus square root 4, b squared minus 4ac, the square root part represents the discriminant, but this part represents our center, and that's our center, and then plus minus to get the roots. So looking at this graph here, we can look at this graph and determine the value of b for one solution. And there's a video where I animated the change in b and see what happens. And the change in b will give us either one solution, 0 solution, or 2 solutions. But we could also do this algebraically by setting up our discriminant. So for one solution, we want to know where the discriminant is equal to 0. So 0 is equal to b squared minus 4ac. We plug in the values for a, b, and c. Okay, so in this case, the big B represents our c value. And when we do that, we end up with 2 squared minus 4 times negative 3 times b. And then we could figure out what b value, what vertical shift will shift that parabola into the right spot. Okay, so we'd have parabola starting with, that's with b equals 0. And then for some b value, we would just vertically shift the graph, and it just touches once. And that b value, when I solve for this, ends up being, this is going to be 0 is equal to 4 plus 12b. 12b is equal to negative 4. b works out to be negative 1/3. So if b is equal to negative 1/3, we end up with one solution. Okay, so if I have b equals to 1/3, I would end up with a picture that looks like this. If b were to be 0 solutions, that would mean that the discriminant, b squared minus 4ac, it must be negative or less than 0. So then we can plug in the same thing again we end up with the same equation. Since 0 is our boundary, on one side of b we're going to have 0 solutions, and on the other side of b we're going to have 2 solutions. Okay, I should actually flip this around because this was actually an upside down parabola that we started with like that, and we shifted it down 1/3 to get to the bounce. Okay, that gives us the one solution here. Now for the 0 solutions, if we shifted it down to get 0 solutions, negative 1/3, if I keep on shifting it down, so less than negative 1/3, I should end up with no solution. So I'm going to plug that back in. 4 times negative 3, the c value was our b value, so it's the same equation here, but now we have an inequality. Solving this, we end up with 12b is less than negative 4. I keep my coefficient positive so I don't have to bother flipping my sign. And if b is less than 1/3, it's going to shift even further down And that's going to start with my graph that looks like this when b is 0. And if I make b equal to negative 1/3, further than negative 1/3, so negative 1/3 will give me the balance, but anything below less than negative 1/3 will give me 0 solutions. So that's what it looks like. For 2 solutions, well, we can probably guess what 2 solutions is going to be. We start with that graph there, and then to get 2 solutions, well, if I shift it down to negative 1/3, that will give me 1. So anything bigger than 1/3, negative 1/3 will give me 2 solutions. So again, I'll set this up, b squared minus 4ac. Now I want that discriminant to be positive. Plug in my values. Solve for this. So then 12b is greater than negative 4, so I end up with the exact same, these are all the exact same equations. The b must be bigger than 1/3. If it's bigger than 1/3, it'll stay above the x-axis, and I have 2 solutions. So that's what my graph's going to look like. I started off with an upside down graph. Okay, it looks something like this. And then as I shift this graph up and down, with the b value, it'll give me 0, 1, 2 solutions. Okay, so this graph that I've graphed here is just going to be the graph with a b value of of 0. Okay, so then as I change the b, we'll be shifting that up and down. So this is there's an animation for this in the next video, so you can watch that to see what happens.